Okay, so part D right here. It says to evaluate that very strange looking thing. Anyone recognize that very strange looking integrand? It's the chain rule. Good, that is the result of the chain rule. Can you guys see that? F prime, g of x, and then g prime of x. So for part D, when we have this entire strange looking thing set up, okay, so what do we write as the antiderivative if that's the chain rule? F of g of x. Good, that is f of g of x. And we're evaluating it from -2 to 3. So this stuff will just all come right off of the packet. All right, so first we plug in the 3. So it's f of g of 3 and then minus f of g of -2. And we have a chart that has all of those values up above. So with this is like a composition thing. So you start with the inside, work your way out. So let's start with the inside here. So f of, look on your chart, what is g of 3? 1. Good. So here's g. If you scroll across to 3, g of 3 is 1. So we're looking at f of 1 minus f of, how about g of -2? Good. That's right there. So g of -2 is -1. And then finally, last step, we will evaluate the rest of this. So f of 1, same thing, comes right off the chart. So if we look at the f row, f of 1 is 2, and then f of -1 is 8. So this is 2 minus 8. Remember we talked about this, since this is the non-calculator section, if for some reason you did not feel confident in your ability to subtract 2 minus 8, you could leave it. I'm hoping that we feel confident in our ability to subtract 2 minus 8, but you never know. Okay, number 5. Questions? No? Good. Okay, so go ahead and flip the page to our last one. So this is our differential equation one. This one's actually a little weird because they're not asking us to graph a slope field ourselves. They're usually asking us to graph a slope field ourselves. So if you read through, here's our differential equation. F is the particular solution with this initial condition. And then it mentions that it's defined for all real numbers. That's a good thing. I don't know if it necessarily is something we're going to have to come back to use. Okay, so part A, it says a portion of the slope field for this differential equation is given below. If you look closely, what sort of function do you see in here? See a sine function. Looks like a sine function, which should make sense because cosine is part of your antiderivative. The 3 minus y is going to change it up a little bit. It's going to give us, can you see right here how the slopes are all 0 when y is 3? So if you plugged it in right there, 3 minus 3, that should make sense. And then I don't think, oh yeah, we see it right here. It's like right here the slopes are 0, if we could get right in between those points, right about here and right about here. So if you look at cosine, what must these x values be right here? Pi over 2 and negative pi over 2. Yeah, so cosine is 0 at pi over 2 and negative pi over 2. Okay, so all they're asking us to do here is sketch the solution curve through 0, 1. Okay, so start at 0, 1, so we've got a point right there. And then this, I'm assuming this is probably a 1-point problem. So as long as you, like, if you were to just graph a negative linear function through here, you'd probably not get that point. But as long as you're semi-following the way that the shape goes. So it looks like over here on the right, it's kind of going up here. And then probably coming back down, right around there. Something like that. And then it looks like it's maybe a little bit steeper off to the left. It's hard to tell. It looks like it goes a little bit lower to the left than it does to the right. Bless you. But as long as you have something that looks like a sine curve. Like I said, if you've got like a parabola or a linear function, they're not going to give you points for that. But if it looks sine curve-ish, you're going to get points. Good? Okay, so that should be a pretty easy point, sketching that particular solution. Part B is a tangent line. So when you guys are doing tangent lines, I highly, highly recommend that you start off with this. Just like write down the point slope form, tangent line, leave it there in front of you, and then you can figure out where all of the pieces come from. So we need to know y1, m, and x1. What do we have so far? They gave us y1, and yeah, they gave us an entire point. So that's like one thing for free. Normally they give us the x value. They don't always give you the y value. All right, so where we're at so far is y minus 1. Yeah?
Wait, is this calculator?
This is non-calculator. Okay, and then the slope, leave a space there. We don't know the slope. X minus 0. Okay, so they gave us the coordinate point 0, 1, so we plug that in for x, plug it in for y. So that's where we're at so far. Next part is we need the slope. How do we find the slope? What's the derivative? Yeah, right here. That's our derivative. So how do we find the slope that we're looking for? Plug in 0, 1. Good, so dy by dx equals, so 3 minus, we plug in 1 for y, and then cosine of 0. Unit circle. What's the cosine of 0? 1. Good, so this slope is 2. So there's your tangent line. Okay, that's part 1 of that question. Are we good with that?
Do we have to move the 1 over?
I would for the next part, because for the next part they're going to ask you to approximate f of 0.2. And this one's super quick and easy, because that's 2 times x, because x minus 0 is just x. So this becomes 2x plus 1.
Well, if you leave it like that.
Oh, you can absolutely leave it like that. Yeah, that's why we've just been doing point and slope for the whole time. But for your next part, it makes more sense to have it in slope-intercept form rather than point slope. So what are they asking you to do with that next part? What does approximate f of 0.2 mean? Plug in 0.2. Plug in 0.2 for x, you'll get an approximation. So y equals 2 times 0.2 and then plus 1. So we get 1.4. They didn't ask you guys here, but a lot of times what they'll ask when they do that, they'll find a tangent line, ask you to use it to approximate something, and then they'll ask, is this approximation an underestimate or an overestimate? Do you know what part of the graph you'd use to answer that question?
It's concave down.
Good, if it's concave down or concave up. So this one isn't always one or the other. There's a portion of it where it's concave up, and then there's a portion where it's concave down. So they wouldn't ask that question for this particular point, but they could ask that question. If a graph is concave down and you've got a tangent line, the tangent line would go up above it. And if a graph is concave up, a tangent line would be down below it. So anytime they ask if a tangent line underestimates or overestimates, it has to do with concavity.
This one's overestimates.
No, this one they couldn't ask you because at 0, 1 is where the concavity changes.
So if it was at the top, it would be over?
Yeah, they could, if they asked you here, if they asked you like at 1 or at 2, it would be an overestimate. Or anything over here would be an underestimate. But that's why they're not asking you here, is because it's hard to tell at 0. I think there's an inflection point there. Okay, last one. This is just the separable differential equation here. So if we start right here, we want to get the dy on one side with the y stuff, the dx on the other side with the x stuff. So this is the separate, integrate, solve for y. So this entire quantity, the 3 minus y, you're going to divide both sides by that quantity. So you'll have 1 over 3 minus y over there with the dy, and then move the dx over to the right-hand side. That's the separate step. Okay, then integrate both sides, integrate the left, integrate the right. Left-hand side? Good. Natural log, careful. Absolute value of 3 minus y, and then because of the 3 minus y in the middle, it's negative. Good. So the 3 minus y, that derivative would be a negative 1. And so it's like that balancing factor when you're undoing the chain rule. So you balance it out with a negative 1. Equals sine x plus c. Good. We just saved ourselves 3 points there. Question?
Why did you plus c on one side and not the other?
We could put it on both sides, but since it's just an arbitrary constant, you could just subtract one from the other and you'd only have it on one side anyway.
Okay.
So yeah, from the beginning of doing these, we've only ever had it on one side. Okay, so 2 choices. Would you guys rather get y by itself now, or would you rather solve for c now? Solve for c? Okay. So our initial condition is 0, 1. So we're going to plug in 0 for x, plug in 1 for y. So we have the negative natural log of the absolute value of 3 minus 1 equals the sine of 0 plus c. Okay, so this is the negative natural log of 2. What's the sign of 0? 0. Okay, so we've got our c. So from this line right here, let's rewrite that line. So negative, and then we'll start to get y by itself. Okay, so now it's like this is our value of c. Remember, once we actually have the value of c, it is affected by everything. Like if you divide both sides by something, or if you multiply both sides by something, it does affect the negative natural log of 2. It wouldn't have affected plain old arbitrary c, because we wouldn't have found it yet, but it does affect the negative natural log of 2. Okay, so a couple algebra moves here. Divide both sides by a negative, or multiply both sides by a negative, or whatever. So negative sine x, and then plus natural log of 2. Then what? Exponentiate base e. Okay, so now on the left-hand side, we have the absolute value of 3 minus y. On the right-hand side, this is, you can split it up to e to the negative sine x, and then times e to the natural log of 2. What is e to the natural log of 2? 2. So this is really 2e to the negative sine x. Are we good with that? Okay. Now, this part is weird. So normally at this stage we had a c right here. What's the actual algebra way to drop the absolute value from the left-hand side? Make the other side plus or minus. Now, because we have a 2 here, we actually do have to make it plus or minus. And you'll see how that all falls together in a couple steps. Okay, so we actually do have to make it plus or minus. Before, when it was a c, when we hadn't solved for c, it didn't matter if we made it plus or minus, because it would work itself out in the end. But now we actually do. So we have 3 minus y, make the right-hand side plus or minus. And then we can subtract that 3 over. And then the last step to get y by itself is either multiply or divide both sides by a negative. So this term, if you divide this term by a negative, then I guess it technically becomes like minus or plus, which doesn't make things any different. So that's still a plus or minus. And then plus 3. So that's your equation. It's not both of them. It's one or the other. Do you know how we determine which one it is?
If it's positive or negative.
What the initial condition is.
Initial condition. Good. The initial condition is 0, 1. So what the initial condition tells me is that if I plug 0 into this equation, I'm supposed to get 1. So knowing that I'm supposed to get 1 will lead me towards either the positive 2 or the negative 2. Yeah, so if I plug in 0 right here, what's the sign of 0? What's e to the 0? 1. So positive 2 would give me 5. Negative 2 would give me 1. I'm assuming many of us would not have remembered the plus or minus, and you wouldn't have gotten the negative 2. That would have lost you your final point. So be careful with that. You would have had the negative 2 if you had saved the c for last. So either way, doesn't really matter, as long as you're careful with all of your algebra rules and stuff.
Can we leave it plus or minus, or do we have to?
No, plus or minus is wrong because it's only one or the other. Because the positive 2 would have given you 5 if you plugged in 0. Oops, that is a negative sign. Okay, questions on that? No? Good? Probably stop.